All right, indicator 7-3 or 7.3 is graphing inequalities. And again, it's very much like graphing equations, only there's a couple of extra steps at the end. The first thing you have to keep in mind is, and hopefully this is a little bit of a review, but when you have either a less than or a greater than sign, you use a dashed line to complete your linear equation. You'll see kind of what it means here in a minute, but that says dashed. And then if you have less than or equal to or greater than or equal to, you use a solid line to complete your linear equation or to connect your points. So where if it's an equal sign, you just draw the line and you're done. Here you have to decide dashed or solid. And then the last thing you have to do is you have to shade. Okay, so kind of step one is deciding dashed or solid. Step two is shading. Those are the two differences between graphing equations and graphing inequalities. So the nice thing is, yes. Let me do one and then I think that'll answer your question. Okay. So for number one, if you recognize, and it's not an equal sign, but if you kind of for a second, just think of it as an equal sign. This is in y equals mx plus b, right? This is in slope intercept form. It's an inequality instead of an equals, but we still have an m and we still have a b. So our m is 3/2 and our b is 2. And we start out the same way, right? We begin with our b, our beginning point is our y-intercept, so a point at +2. And then we go up 1, 2, 3 over 2, or we could go down 1, 2, 3 and backwards 2. I like to do both to give myself a good structure for a nice straight line. And then we need to ask ourselves, right? This is where it changes from the difference between equation and inequality, because if this was an equation, I would just draw my line and be done, but it's an inequality. So I have to ask myself dashed or solid, and you answer that question based on your inequality sign. And in this case, it's a less than, so it'd be dashed. So we connect all the way across our graph, and we want to go all the way across, and I'll show you why here in a second, all the way across with arrows top and bottom with a dashed line. And now this is when the shading comes in. And I teach it this way every year, and it really does kind of help clear up, because shading tends to be what is the most challenging part of this indicator. So here's how I teach you guys how to do it. Go back with your pencil and put your pencil back on your beginning point, and I'll do it in a highlighted red so you'll see where I do it. But I put my pencil right there on that highlighted point, which was my beginning point. Leaving my pencil, whoops, I'm sliding. Leaving my pencil there, look at your original equation, and it's y less than, now don't worry about the slope, y less than your original point. Well, which y's are less than 2? It's these y's, right? If you're just thinking about the y's, those are the y's that are less than your original b. And that tells you that you shade everything on that side of the equation.
What?
We'll do a couple. To determine which side of the line you shade, you go to your B, you hover your pencil over the B, and then I kind of got a little overshot there. There we go. You go to your B, you hover your pencil over the B, and then you go back to your original equation and you look at all y, you just read it, y less than 2, because that's where your B was. So what y's on your graph, what y's are less than 2? Well, it's the y's underneath 2. I'm just talking about the y-intercept here. What y's are less than 2? Well, it's the y's underneath it. So then when I shade that, then that tells me which side of the line to shade. Okay. Want to do another one like that again, and then we'll look at special cases. So we're going to jump to this one. I'll give everybody a chance to sketch this down. I think to help save time tomorrow when we do absolute values, I'll probably print off notes for you that already have graphs. I think that'll probably be helpful. I should have done that for today, but I just didn't think about it. All right, so again, you should recognize this is slope-intercept form. It's y equals mx, and then what's our b here? It's not there, but it's there. Logan? Yeah, it's there, but it's not there. It's a 0. So my slope is -2/5, and my b is 0. Again, I'm going to start off like I would if it was an equation. I'm going to go to my b, and I'm going to put my beginning point on the y-intercept, which in this case is 0. And then I'm going to use my slope to either drop 2 and go right 5 or raise 2 and go backward 5. Okay, again, I like to do both if I can, just to give myself a nice structure here. Is this going to be dashed or solid? Dashed. So I'm going to connect my points here with a nice dashed line all the way across my graph, arrows on both ends. And now the shading part comes in. Okay, hover your pencil over your B or where you started. And then look at your equation. It was all y's greater than 0. Well, if you just look at your y-axis, these are the y's that are greater than 0. And since they are above your line, you shade everything above your line. So if you do it this way, you should have a darkened y, part of your y-intercept should be darkened, either above or below your intercept should be darkened. And then that tells you which side to go back and lightly shade. Okay. And I'm going to do one with all black just so it'll kind of look like what your pencil looks like. All right. So what about special cases? We still have special cases, x equals and y equals in inequalities. And we start out the same way. So I'm going to just do this all with like a black, what I would call a black pencil here. So it'll kind of mimic what yours will look like. So I've got x is less than 2. Well, that's my x-axis only, right? It's a special case. So I put a point at x equals 2. And I know that x's go up and down. And is this going to be dashed or solid? So up and down, all the way across or all the way down. I'm going to do a nice dashed line with arrows top and bottom. And now I'm going to take my pencil and I'm going to put it right back on my original beginning point. And then I'm going to look at my equation and it's all x's less than 2. Well, on the x-axis, these are the x's less than 2, right? Everybody agree that those would be the x's less than 2? So then I just come back with my pencil. And when I say shade, you don't have to, it doesn't have to be solid as long as I can tell left or right which way you're doing. So you can see that I kind of gave myself a basis for which way I'm going to shade based on my beginning point. And then once I know which way to shade, then I go back and actually shade my line or shade my graph. Okay, another special case is a y. We're familiar with this, right? So if it's y and -4, I go to my y-axis. And on my y-axis, I put a point at -4. And it's y's horizon, right? So I know my y's are going to go side to side. Is this going to be dashed or solid? Solid. So I'm going to draw me a nice solid line here. And then I'm going to go back to my original point that I plotted, and I'm going to look at my equation, and it says all y's greater than -4. Well, on my y-axis, these are the y's greater than -4. So that tells me I'm going to shade above. Sound good? All right. The only other form that you're going to see on this is when it is in standard form. Now, the rule that you need to remember, and I'll write it here at the bottom, this is a special rule for inequalities. Does anybody remember what it is? About flipping the sign?
When you multiply or divide by a negative number.
Yep. If you multiply or divide by a negative number, you flip your sign. Okay. If you don't remember to flip your sign, your shading is going to be on the wrong side. So you do need to remember that rule. So we're going to do 2 examples from standard form, and then we'll be done with notes. All right. Does everybody have the rule down? Am I good? Oh, I'll wait. All right. So let's zoom in here on number 5 example. We can't graph from standard form, so we need to do a little bit of algebra here, and we're going to subtract 2x from both sides. And when we do that, we're left with 5y is less than negative 2x plus 0. We still need to get, because we want to get it in slope intercept. So we're going to divide by 5, and divide by 5. And that gets me y is less than negative 2x plus 0, because 0 divided by 5 is 0. Now notice my sign didn't change because I divided by a positive 5. Okay, so my sign didn't change. What'd I do? Oh, yep. I saw some questionable faces, so I figured I did something. There we go. Negative 2/5. I forgot my dividing by 5. All right, so now my m is negative 2/5, my b is 0. So I can start by graphing my b, or my beginning point, at 0. And then I use my m to move either down 2 and to the right 5, or up 2 and backwards 5. And now am I going to do dashed or solid? Okay, I'm going to do a dashed line. Whoops, let me do that in black. All right, so I've got my dashed line. Arrows on both ends. Now, remember when I said when you're shading, go back to your original. That's not quite true. You want to go back to, always go back to slope intercept form, because standard form does not help you a bit knowing which side to shade. Okay. So go back to where you got it in y equals mx plus b. Then put your pencil right on your b, and then look at it. It's all y's less than 0. Well, these are the y's that are less than 0, which means I'm going to shade this bottom portion. So when it's in standard form, it's a little bit more work because you have to do the work to get it into slope intercept form first. And we're going to do one more example, and then we will be ready to go on your homework. All right, so it's in standard form. I need to get it into y equals mx plus b, and I'll wait just a second, give everybody a chance to jot the problem down. All right, so I'm going to start by moving my x over, so minus 9x from both sides. And when I do that, notice it's negative 5y that is left behind. Negative 5y is less than or equal to, I'm going to write the x value first, so negative 9x plus 25. Now, I'm going to divide this negative 5 off. As soon as I divide by a negative, I'm going to do it right now because I don't want to forget. I'm going to drop down here and I'm going to flip my sign. And I like to do it right away so that I don't forget once I start reducing everything. I don't want to forget. So I like to just drop down and do it right away. But because I divided by a negative 5, that rule comes into place where I flip my sign. And so now it's a greater than instead of a less than. And now I reduce everything. I get y negative 9 over negative 5 is positive 9/5 x. And positive 25 minus 5 or divided by negative 5 is minus 5. My M is 9/5. My B is a negative 5. And just as a reminder, when I go to shade, I'm going to use my slope intercept form as my reference for shading. So I'm going to plot my B, which is my y-intercept at -5. Then I'm going to use my M to move. So I'm going to go up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. To the right, 1, 2, 3, 4, 5. That's a positive and a positive move. Keeps my line positive. Am I going to be dashed or solid here? Solid. So all the way across, I connect it with a nice straight solid line, arrows on both ends. And now to shade, I'm going to go back and I'm going to hover over my original B, which was -5. And then I'm going to look at my equation and it's all y's greater than -5. Well, these are the y's on the y-axis that are greater than -5. They're trapped on that upper part or the above side. So that means I'm going to shade that. Pretty good? Any questions? All right. Again, if it's already in y equals mx plus b, great. State your M, state your B, graph, decide dashed or solid and shade. If it's a special case, it's either going to be up and down or side to side. And if it's in standard form, you have to get it in y equals mx plus b, remembering the rule about the dividing or multiplying by a negative. Okay. All right. For those of you at home, email me if you have any questions. Otherwise, show all your work and pull it up on Cami.